All right, let's look at this example. So we have here Farmer Ed has 850 meters of fencing and wants to enclose a rectangular plot that borders on a river. If Farmer Ed does not fence the side along the river, find the length and width of the plot that will maximize the area. What is the largest area that can be enclosed? So we have three questions that's being asked of us. To find the length, number one, to find the width, number two, and then number three, find the largest area that can be enclosed. All right, so since we're talking about length and width and area, we're going to be using the area formula. A is equal to length times the width. And we're going to let L represent the length, which will be 850 minus 2x, and we're going to let W represent x, the width, equal to x. Okay, so we're going to let the width be x and the length be 850 minus 2x. Okay. All right. So, um, let's set up this equation. So, putting those together, we have A is equal to the meaning area, the length, which is 850 minus 2x times the width, which is x. So what we can do here is take this x and distribute that to the 850 and to the negative 2x. So we have here 850x minus 2x squared. And we're going to write this in standard form just so that you can look and see how this is going to form here. So let's just write it in descending order. Negative 2x squared plus 850x. Okay, so the question is asking us to, what would be the maximum value or maximum area? Find the length and width of the plot that will maximize this area. Okay, so we know that since our A here is negative 2, this would be somewhat of a parabola. Well, it is a parabola because it's the highest degree is x squared, but because the 2 is negative, it's going to open downward. So we want to find the maximum value. So to find the maximum value, we're going to use our formula. X is where we would normally find the vertex. So x is equal to negative times b all over 2a. Okay, so let's plug in the value. A is going to be negative 2, B is going to be 850. So we have negative times 850 all over 2 times negative 2. So this is negative 850 over negative 4. And then that gives us what here? 212.5. And this is measured in meters. Okay. All right. So what is 212.5 meters? Well, this would be, we said let x represent the width. So the width here, we'll write it here, 212.5 meters. Now we need to find the length. We want to find the length. So what we're going to do, we're going to go back to this formula. A is equal to 850x oh, excuse me, go back to, I'm sorry, not A is equal to 850x. We're going to find, we already defined what the length is. So 850 minus 2x. Therefore, we're saying 850. We're going to plug in where we see x, we're going to plug in 212.5. So 850 minus 2 times 212.5. And then multiply 2 times 212.5. Subtract 850 from it, and we're going to have 425 meters as our length. So this is our length. We have our width. Now part C says to find, or the last sentence, what is the largest area that can be enclosed? Well, now that we have the length and width, multiply 425 to 212.5, and we're going to say meters for each. And then we have here 90,312.5 square meters, because area is measured in square units. So this would be the answer to our last question.